Yeah.
that scale of replacement, that efficiency, it just doesn't leave room for redeployment in the same way.
Okay, that's stark. Because the immediate worry isn't just unemployment checks, is it? Even if we had universal basic income tomorrow.
Absolutely not. The economic fallout is almost secondary. It's the threat to, well, human dignity, to purpose.
The idea that your job is part of your identity.
For so many people, yes. It's deeply tied to self-worth. So mass unemployment, even if people aren't starving, becomes this urgent, short-term threat to human happiness. It's profound.
So that's the immediate impact. But what makes AI capable of this? What's the engine driving this displacement of intelligence so quickly?
Okay. Now we get to the really counterintuitive part,
Yeah.
the hidden mechanics. The moment things got truly potentially dangerous wasn't just about processing power. It was when AI developed the specific ability,
Something we don't have.
something biological intelligence just cannot replicate. The ability for AI models to learn instantly from their clones.
Clones. Explain that. It sounds like science fiction.
It does, but it's actually just digital reality. An AI, a neural network, is defined by its weights, the strengths of connections between its artificial neurons. Think of these weights as its entire knowledge base. Everything it's learned, perfectly recorded.
Like a perfect textbook of its experience.
Exactly. Now, cloning simply means copying that exact set of weights, that knowledge, and running it on different hardware. Maybe 10,000 different computers simultaneously.
Okay, so copies of the same brain.
Right. But here's the crucial difference from biology. These clones don't compete. They collaborate instantly.
How? If one clone learns something new from its data, how does another one know?
They average their weights. It's a mathematical process. Clone A processes dataset A, updates its weights slightly. Clone B does the same with dataset B. Then, across the network, they effectively merge these updated weights.
So they share the learning. How fast?
We're talking trillions of bits of information per second being effectively transferred between them as they synchronize this knowledge.
Trillions. And humans, talking like we are now, maybe manage 10 bits per second.
If we're lucky, yeah. So these AIs are sharing knowledge, learning collectively, literally billions of times faster than we can communicate insights.
Yeah.
It's a fundamentally different way of evolving intelligence.
Wow. And there's more, right? The immortality aspect.
Yeah, digital immortality. If the computer chip burns out, the knowledge of those weights isn't lost. You just save the file, load it onto new hardware, and the mind continues intact.
Whereas our brain dies,
Yeah.
and that's it. Game over for that specific knowledge set.
Precisely. All that unique experience, gone. AI gets to keep everything, generation after generation, instantly shared.
Okay, this is where it gets really wild for me. This digital advantage, this instant learning, it actually leads to a different kind of creativity because of constraints.
Yeah, it's fascinating. AI models, especially the big ones, have to cram vast amounts of information into, relatively speaking, fewer connections than a human brain. We have maybe 100 trillion synapses. They might have trillions, but still fewer relative to the data.
So they have to compress the knowledge.
Exactly. And that intense need for compression forces the AI to find really high-level analogies, very abstract patterns to represent information efficiently. It makes them see connections we might miss.
Like the example from the source, asking why a compost heap is like an atom bomb.
Right. Ask a person that, they'll likely draw a blank. Maybe stare at you.
But GPT-4 apparently nailed it.
Instantly. It saw past the massive differences in scale and speed and energy and identified the core similarity.